Hello students, this is Anjali Diwalkar. Today I am going to cover a portion of connected bodies in equilibrium. Okay, we'll deal with one problem. In a last video also I have told you about connected bodies. If connected portion is given to you means what? There will be a more than two supports. Okay, so if they are connected, there will be a common portion. Okay, then there will be a more number of unknowns that is more than three. So we do have only three equations of equilibrium, and we can't solve it by if there are more than three unknowns. So what we used to do, we used to separate them, okay, and then we used to find out its reaction components or its tension, whatever is being asked to us. Okay, we'll deal with one another problem. A block A of weight 100 Newton and B of weight 200 Newton are connected to each other as shown. Okay, they are held in equilibrium on a smooth slope and rope tied parallel to the slope. Find the external support reactions and tension in connecting rope. Okay, so we'll find out what are the steps we are going to follow. Draw a video of separate portion, okay, separate block and mark unknown reactions. Apply condition of equilibrium on each block, then find out unknowns. So please concentrate on the FBD of every block. This is a A block and this is a B block. What we can see over here, its weight, how many forces will be there? It is resting on this surface. There will be a perpendicular reaction, its own weight, okay, and and last one is a tension in this rope, okay. So I told you so many times there will be a perpendicular reaction perpendicular to this surface. So here its inclination will be 90 degree. But on this horizontal surface, if the surface is inclined by 30 degree, then your reaction will be inclined by 60 degree. 90 minus this theta. Okay, for that reason Ra is acting like this and its inclination with horizontal is 60 degree. Weight will be straightly acting downward. Okay, it is very much known to us, weight will be always downward. Though your block is resting on horizontal surface or inclined surface, its weight will be vertically downward. Okay, we'll draw the FBD of this B block. See, the important portion is this only, drawing FBD. Once you are very clear about this concept, you can use conditions of equilibrium and you can happily find out the number of unknowns. When you know the forces, you can find out it. Okay, see, it is resting on this surface, so there will be a perpendicular reaction through B. Its self weight will be acting, and two tensions. One is going on A and one is on this surface. So T1 and T2. Why I have marked T1 and T2 over here? It is being given to us rope 1 and rope 2. So rope 1 will be having T1 and rope 2 will be having T2. See, please do remember this. Whenever there is a connection, if T2 is going from this block to on that B block, then T2 from B should be going on A block. Okay, if I make a mistake and I draw this like this, then there will not be any equilibrium and we are going to get the different values for T2. Okay, so we cannot tally it. Okay, do remember, by if they are acting like this, then and only then they will nullify each other. Okay, then we'll move on. We'll consider one block A. Why I have considered block A? On a block B, there are three unknowns, and here only two unknowns are there. Okay, so we'll go here. Here also we can solve, but it will be simpler if we go by this block. So we'll apply summation fx and summation upon on this block. 100 weight is given to us. Okay, summation fx equal to 0. It will not reflect in fx because only horizontal components will reflect in summation fx. This is going rightward and this is leftward and this is going rightward. So it will be negative, it will be positive. Minus Ra cos 60 plus T2 cos 30 is equal to 0. I hope you are okay with this inclination. These are the inclinations given in our FBD. Okay. Sorry. Summation F equal to 0. Ra sine 60 will be the component going upward. T2 sine 30 will be the going upward. Okay. Minus 100 is equal to 0. By putting it, we'll find out one equation. Here also we do have one equation. We'll put Ra in terms of T2. Okay. From that we can find out value of T2. Once I know T2, I can put that value in this equation and we can find out Ra. Okay. We'll move to next block. Okay, now considering block B, this is a 50 we have found in the last step. This is T1, RB, and 200 downward. Again, we'll apply summation fx and summation fy on it. In fx, two components will be there. In RB also, one component will be there. In fx, 50's component will be there. RB's component will be there, and T1 component will be there. This will be negative, this will be negative, this will be positive. Sorry. Minus 50 cos 30 minus RB cos 60 plus T1 cos 30 is equal to 0. Sorry. RB sin 60 positive, T1 sin 30 positive, minus 50 sin 30 minus 200. See here it will go downward. By solving it, we can find T1 and RB. Okay. Very sorry. We'll deal with another problem. Determine horizontal and vertical components of force that P set A and C. Find angles, mark reactions, and apply conditions of equilibrium. See what we are going to do. Again, it is a connected body. It is connected at B. These dimensions are given to us. Okay. It's a one kind of frame actually. What we are supposed to do, we'll separate this portion at B and this portion at also. Again B. These angles are not known to us. So we'll find out this angle. To find out angle, what must be known to us? This kind of geometry. This is 0.9 and this is 0.9. We can happily say this will be 45. Here this vertical dimension is 0.8, horizontal is 1.2. Then tan alpha is equal to 0.8 divided by 1.2. In this way we can find out the angles. Okay. Here I have did it. Okay. So alpha will be 41.63 and theta will be 45. I have drawn this FBDs also. See, please look at this portion only. If RBV is going down, RBV here in a BC portion should be upward. Then and only then you can correct the problem. Okay. RBH in this portion is going leftward. It has to be rightward in this portion. Okay. RBH is going rightward. For that reason, RCH I have marked in a leftward direction. Okay. RBV was going upward. RC is going downward. Okay. Then this 500 is given to me. RAH and RAV I have marked like this. For that reason, it will be downward. We'll first of all consider AB. As there is no load in this portion, I cannot solve this BC portion first. Okay, so I need to solve this and then we'll carry forward this value to this B and we'll work out C. Okay, consider part AB. Then summation fx equal to 0, RAH and RBH is equal to 0. There is no load. So we can say RH is equal to RBH. Okay, summation fy equal to 0. What we'll do? RAV minus 500 minus RBV is equal to 0. We'll have one equation. We'll take a moment about it. 500 into this horizontal distance and RBV is into complete distance. So these distances are given to us. 500 into 0.5 and RBV is somewhere here. So RBV into 0.9. Both are clockwise. So positive. Minus RBH into 0.9. Okay, is equal to 0. See, we are taking moment over here. RBH is here. So whenever force is horizontal, our distance will be vertical, which is given to me. This is 0.9. Okay. So by solving this, we can find out one equation in terms of RBV and RBH. Okay. So consider part BC now. We'll consider part BC, summation of x equal to 0. From there also we can come to know RBH is equal to RCH. By applying summation of y equal to 0, RPV minus RCV is equal to 0. From that we come to know RPV is equal to RCV. Now we'll take a moment about see what will happen. RBV into 0.2 plus RBH into 0.8 is equal to 0. Then here we find out one equation in terms of RBV and RBH. So RBH is like this. So in last equation, we can replace RBV by 0.67 RBH and we can find out RBH over here. Okay, we'll put those values and we'll find out the values of RBH, that is 166.33. Then RBV is equal to 151.44. Sorry, 111.44. We'll put those values over here and we can find out RAH and RBV. Here we need to take a care of signs of reaction. If we get negative answers, we are supposed to change the sign in answer. Okay. Thank you.